Okay, what we're going to go over is our Barbie Bungee activity, the math practice sheet, and we're going to look at example B. Okay, so first thing that we have here is we have some data in regards to how many hours of studying per week students put in and their average test score, which may sound somewhat familiar to many of you. So if we look at our data, we have our number of hours studying per week, and we're going to label that as our X, and our average test score is going to be our Y. And you can see that I am starting to set up my graph. So set up your X and Y axis with your hours of studying on the X axis, and we're going to go by ones, and I want you to go up to 10, and then you're going to do your Y axis, and you're going to go up to 100. Alright, and once we have our graph set up, let's just add our labels. So we have hours studying, and on the y-axis we have test scores. Okay, and so you can see that I've already plotted my first point, and so our first point was 1 hour a week. If you studied 1 hour a week, you students got an average test score of a 60. If they studied 2 hours a week, they got an average score of a 67. 3 hours a week was a 78. 4 hours a week was an average of an 82. 5 hours a week was an average of an 88. And if students put in 6 hours a week, they had an average of a 93. So we've plotted all of our data. All right, we've made our scatter plot, and now we need to use a ruler, right, and we want to draw a line of best fit. Now again, your line might be a little bit different than mine. It's okay, but I would like you to try to use my example to the best of your ability. So if I look at it, remember the line of best fit means that if this data was to continue, all right, and if we looked at 7 hours studying per week, 8 hours studying per week, all right, we should see a consistent pattern of points. And so if I were to draw a line, I want to kind of split the difference between all the points, and so I have kind of the same number above and below the line. And so here's my line. Again, not the best, but not the worst, but it's okay. So you see I've made my line, and the next thing I need to do is I need to pick 2 points on the line. And remember, what I meant by 2 points is on the line is where our X and our Y axis intersect on the line. So you can start to see I actually made an X where that happened, and that actually was one of our given points. So one of my points on the line you can see is where the X is. It's at 1 and 60, and then my next point, if you look down past all of the points that I plotted, you'll see that the next point where the red line goes through a corner where the X and the Y meet is way down here. And so the 2 points I want to use are 160 and 110. So I'm going to move on to number 3, and so the 2 points I picked, I'm going to write them down. So I have 160 and 110, and I've just skipped slides. So if I go back real quick, all right, you see the graph, and now I'm just going to move to questions 3 through 6, and we just can't see everything on the same page. So if you need to go back, use your graph, but you're not going to see the graph on the next slide. So if we move forward, I'm just rewriting my points, 160 and 110. And now this is where things should look familiar with what you did with Mr. Goovin. So with Mr. Goovin, he had you then put those points in a table. So we have X is 1, Y is 60, 9 is 110. I'm sorry, X is 9 and Y is 110. All right. So moving down to number 4, we need to find the equation of a best fit line using the 2 points in slope-intercept form, which is Y equals mx plus b. So finding the slope of the line. This is where we use delta y over delta x. And so remember Mr. Goovin's little rap. Wake up in the morning, it was 60 degrees. Go to bed at night, it was 110 degrees. But basically, we're finding the difference in change. So how much did the values change from 60 to 110? That's our delta. So that's 50. And that'll be, then we want to find out how much did it change for our x, 1 to 9. And that's a difference of 8. So we want to divide 50 by 8, and we get 6.25, and 6.25 then becomes our slope, all right, which is m. So we're going to reference this again later for question number 5, but slope is 6.25. So that means if we looked at it, it kind of increases as an average of 6.25. So moving on to B, now we need to find the y-intercept, which means we actually have to find the value for B. So we're going to use our formula, y equals mx plus b, and we then plug in our m, so it's y equals 6.25 times x plus b. And if you remember, we then go back and we use 2 of our points, and we're going to use, and I have an orange highlighter, we're going to use up here, all right, our point for 1 and 60. So we plug in 60 for the y value and 1 for the x, so our new equation looks like 60 equals 6.25 times 1 plus b, and now we need to solve for b. So it's actually pretty easy. 6.25 times 1 is 6.25 plus b. Then we subtract 6.25 from both sides, and we'll end up at the end with 53.75, which is our b value. So now we have our m, which is our slope-intercept, and we have our y-intercept, which is 53.75. And the y-intercept means if we actually go back and look at the graph really quick, right, the y-intercept, that's where our line we drew, that's where it goes across the y-axis. So again, I have my orange, 53.75.